Welcome everybody, my name is Chana Saminathan. I'm a Solutions Architect with AWS. This is a segment of the reInvent Builders Fair. The title of the segment is Virtual Awesome Mind, Dynamic Code Breaking in the Cloud with Machine Vision and IoT. Before I start, I just want to take a moment to talk about these principles we hold at AWS and Amazon, and they are to work hard, to have fun, and to make history. And today's presentation is about the middle one there, to have fun. So being part of reInvent and getting the chance to present is an honor and one that we take very seriously. However, to be in the Builders Fair is all about having fun also. So we work hard every day and we try to have fun along the way, and perhaps what we do will make history sometimes. But I just want to caveat that this talk is going to be about showcasing something that's inventive and something that I built for this year's reInvent. And I hope that you enjoy it and it persuades you to build on and build something creative as well. Here's a high-level agenda of what I'll be talking through today. I'll talk about what the inspiration was for the project and a bit about background about it. Briefly touch on the IoT progressive web applications, talk through the architecture of the solution itself, give a thorough demo of the project and run through the code and how you can extend it further yourself. And there'll be 9 different office hours that we're going to have for every project this year. So be sure to take note of the times when I share that. And I look forward to talking with you at one of those times to share the project further and playing the game with you as well. Lastly, the information that we're going to be providing you will have all the diagrams, the slides, and the GitHub code for all of this. So including the bill of materials for the Raspberry Pi and all of the pieces so you can go ahead and make this yourself. Okay. A little bit of introduction about myself. So my background is in telecom for 22 years, and I worked in mobile signaling protocols for much of that time. And my claim to fame was that I was sending GSM SMS messages back in 1996, but not for plain texting. It was for the engineering of voicemail indicators for mobile phones back in 1996. And I've been at AWS for 20 months now, and the first 13 months was spent on the AWS research and development team building prototypes for customers. And about 7 months ago, I moved over to a field solutions architect role as I really missed that interaction with the customers that I used to have before. And I consider myself a true builder at heart, and I love to build things, especially using our cloud services, and I like to tinker and create things even if they don't really have a practical application yet. And I have a passion for the concept of Internet of Things and having things connected into the cloud. So that's something that I'm looking to specialize in the future. So I hope you can enjoy what I built here today. Okay, a little bit about the inspiration and background now. So the picture on the right is of me and our family pet Tux. As you can see, he loved to be with me in my den, and I dedicate this project to him as he is one of my inspirations. Now, let me tell you a bit about our previous project. I was only 5 months in at AWS, and I had this idea which got selected for the reInvent Builders Fair. The project started off as myself simply wanting to connect a sensor up to our IoT service and seeing the opening and closing of a switch being reflected in the cloud. So then it grew into something a little bit bigger where I was able to measure the opening and closing of doors in our offices, where I hooked up these switches to 4 doors in our offices, and I was able to measure the foot traffic of people coming in and out of the doors being opened and closed throughout the span of 2 days. And once that was selected for the Builders Fair 2019, I had to enhance it, and I chose to gamify it somewhat and to make it into what I called a door puzzle, hence the name and stickers from last year of the IoT door puzzle. My colleague and friend Cameron Wilkes helped me with this project, and we manned the booth for 2 days at Builders Fair 2019 to talk to customers. And at the end of those 2 days, we were pleasantly surprised when we were one of 7 from various areas of the reInvent that was invited to come and speak at the AWS India user group and also showcase our demo at the AWS Summit in Dubai. So for this year, I wanted to learn and raise the bar even further, as my aspiration is to become a member of the AWS IoT technical field community and specialize in IoT. So I started with something which I saw last year that somebody else had done, and I started from the end result and worked backwards from that. So this is what gave me the idea for this year. The picture on the left is from a video at the Sydney Summit where John Rosenstein of AWS chose to be very frugal in his project and used Postit notes to represent farm animals. He used a deep lens camera to look at the various colors and direction, which is indicated by the black triangles, and he took coordinates and he sent these coordinates up to the AWS core service. And from there, he overlaid some farm animals in those coordinates and displayed them on an Amazon Sumerian rendition of the farm itself. So as you move the Postit notes around, it simply moves the animals around also and is reflected back that way. Well, my interest in puzzles and code breaking, I had this idea of using Post-it notes to play a game of Mastermind in the cloud. Mastermind is a game which I played growing up in the 1980s, and the idea is that one player simply creates a code with the four marbles there and hides that code. The other player takes turns guessing the correct color and the order of that code itself. The player who created the code can only give hints of how many colors are correct and also how many of the correct colors are in the correct position itself. So here you can see that in the first turn at the top, they have two blue marbles. So the white peg indicates that a correct color is there, but not a correct position. In the next row, there's a red marble, and it is in the correct place, as well as a purple marble, which is not in the right place. So the game simply goes on like this until they actually break the code or they run out of turns. So I took a similar approach of shuffling Post-it notes to represent the marbles, but also wanted to see if our IoT services can simply handle the load of doing large numbers of messages in a progressive web application where a user is simply moving objects around and the camera is going to be converting the movements into data and then sending that data into the cloud to be interpreted and match the unknown code itself. A little bit about progressive web applications now. So progressive web application is something that uses modern web capabilities to deliver an app-like experience to the users. More and more companies are starting to use IoT services to enable them to offer those types of experiences for the customers. My Builder Fair project from last year is a very rudimentary form of one where the user can interact with some devices which communicates over the web to some service, and the results are immediately in real time reflected back to the user. The locker that's shown here was a standby locker we had for the stickers. So the locker sent up the information in real time to IoT Core, and then the Raspberry Pi, which is shown there with the SenseAt display, would pull that shadow about 10 times a second to get that information that's reflected back in near real time. In today's demo, I'll be going to something very similar, but a much larger scale of sending about 50 messages per second into the IoT Core. Okay, a little bit about the architecture now. The architecture is really not tremendously exciting as it's really, really simple. All the drawings and the code will be provided as part of the reInvent experience, so please look out for them and use them to build on and build something that you want to extend from this project. So for this project, I'm using a web camera connected to a Raspberry Pi 4B, and it's using the CV2 libraries, the computer vision libraries, to take a picture and then identify some colored objects and then putting a marker on those objects and seeing what that order is. Then it's going to be passing those coordinates into the AWS cloud and into IoT Core. And the scale for this project is, like I said, about sending 50 messages a second into the IoT Core and having those messages being reflected back in real time into what we call the IoT Core shadow. This year I didn't do anything with the information, but it's easy to pull the shadow and extend this to other types of applications, which I've shown here. So from the IoT Core, I have it going into our Dynamo database and QuickSight, but you can really send it to many other services depending on how you want to enhance the project. I've shown a listing of some of the services that you can send it to for other types of processing. For example, you can send it to IoT from the IoT to Lambda and kick off some other types of function or service that you want to do. You can send it to SNS and send it out an SMS or send out an email for that matter. And you can even send it to SQSQ and have some other service that's going to come and take action on each of the messages themselves. And you could either store the message, do it, where Q comes in and takes that message. So it's really up to you. There's many, many things that you can keep doing with the messages once it's in IoT Core. Okay, now for the fun stuff here. So let me take you through the demo and show you how the project works and get into all the details a little bit more. Now, before I get into the actual demo, let me take a little bit of time to share the experience with computer vision, which is completely new to me. So to get the nicely contoured, identified, ordered Post-its to look, like they're being recognized, I had to work with the color matching first of all. So computer vision was entirely new to me, but it was fun to learn how computers can visualize things based on what we call the hue, the saturation, and the lighting values. So I had to define what each of the colors were to the webcam that I was using. So you can see here on this the middle picture there, although the colors were being somewhat recognized, it was very hard to draw contours because, as you can see, the shadows of the lighting, the different types of colors that were there, the background in the room, the lighting, from the side window, all of those things go into this. As you can see, some of the pictures on the left there, when you're trying to identify something, simple as the color blue, and you're putting the different hue, saturation, and such, it makes the colors look a little bit different. So you had to kind of fine tune those values, and I'll show that a little bit later there. So as you can see, the colors were not perfect at first, and nor was it easy to tell the camera how to put those contours around it. But once I identified the contours around the object, I put a colored dot, and that colored dot was to represent the topmost place of that contour, and that's what you see on the bottom picture there. And it was only then that I realized that my original plans to use the AWS Deep Lens camera as I had planned was not possible. It simply didn't have the power to reflect the work that needed to be done of sending all those messages. So I kind of backed off there, and I went to a Raspberry Pi 4B with a simple webcam as shown there, and that was more than enough for the task that I wanted to do. Now, I wanted to show you this also so you can appreciate the speed of the AWS IoT services and how it can be used for various applications. The locker has a switch at the top of the door, as you'll see here, and it's going to be connected to a Raspberry Pi right behind it. And every time you open or close the door, it's going to send a signal to the IoT core in Virginia. The green window is a terminal showing the Raspberry Pi, but the shadow state with open and close are messages that are coming back from Virginia as the door is open and closed. So you can see as the door is open or closed, it's being reflected from the west coast of the United States all the way across to Virginia, across the country, and coming back, and that's what you see being shown as open or closed there. So you can see how fast that is. As the doors open and close rapidly, it keeps up with it, and that's pretty fast there. So that's the speed of the IoT services within AWS. Okay. Now, I'll do a run through of the project and talk through the code that I created, as well as show you a demo of it with the AWS IoT Core Shadow. Keep in mind, all the messages that you're going to be seeing from the west coast of the United States are going to be going across the country to a data center in Virginia, and then being shown on the IoT AWS console screen in near real time. And that's what I was looking for. I wanted to have this gamified, to have that interaction from a customer for a certain application, in this case, playing a real responsive game, and you'll see how fast that really worked. And so at the end, I'll kind of walk through a little bit about how this project can be also extended for other types of use cases. So let me go ahead and start the video, and then we'll go ahead and talk through that. So what you see here are three different windows, and the one on the left here is going to be the Python script that's running the starting of the game itself. The middle picture there is going to be the AWS Management Console, and the right side is going to be the Python script that I ran. So if we kind of go ahead and start off on the left side here, and I'll just kind of talk through that as the video is playing there. So you can see at the top you have these four different numbers that are being selected. In this case, it's going to be blue, orange, yellow, and purple. And what you have is you have 6 different numbers, originally the 6 colors. And if you are able to match 4 colors, that means that there's going to be 720 different combinations of them. So what we're doing is we're selecting 4 colors randomly. And in this case, again, it's going to be blue, orange, yellow, and purple. And what I'm showing there is it's going to be sent up into the cloud, into the shadow state of IoT, and it's going to be stored there so we can match against them. Okay. So now if I go into the AWS Management Console, you can see all the different services of AWS. These are all the services, and there's going to be more of these, than before. And as I click into the AWS core here, you'll see the startup screen for the AWS IoT Core. And I'm going to go ahead and drop into the Manage section. And in the Manage section, there's going to be things. So we have things that are connected to the cloud, the Internet of Things. So the one I have connected here is my Raspberry Pi. I dropped down into there, and we're going to take a look at the shadow state. So the shadow state is really where information is going to be sent up, as I mentioned. And if you click into the AWS shadow, you'll see there's what's called a classic shadow there, and it's going to represent information from the last time this was run. So that has the blue, orange, and I'm going to go ahead and delete that out. So when you delete it, because there's something connected, it throws out the error message. And what I'm going to do is I'm going to go ahead and start up the game again. So once the game is started, it's going to randomly generate a certain sequence of colors, and you'll see that it's going to generate those, send them into the new shadow, and they're represented right there. So in this case, it's going to be yellow, pink, orange, and blue. So you can see the yellow, pink, orange, and blue was generated, sent those messages into the cloud, and now those are in the shadow state itself. Okay, then the game is going to go ahead and just start playing, and you can stop it and start at any time. So if I restart it here again, this time it's going to be blue, orange, yellow, purple, and if I go ahead and refresh the console, you'll see once it's refreshed there, it's going to pick up that information. And I'm just showing you here really how fast this is going back and forth. So the game stopped again. I'm just going to restart it one more time here, and then I'm going to go into the other pieces. So the current colors that are there is the blue, orange, yellow, and purple. Now, to go into the code itself, what I wrote here, on this screen, you'll see the output on the bottom. This is the output that came as I was running the code earlier. And I'll kind of talk through the code at a high level and then explain what all the different components were. And keep in mind, you'll have access to all of this once the code is released to you. This is a standard Python code. At the bottom here, we have a while true, meaning keep doing this loop over and over and running this game. And all we're really doing is to say find colors. And within that method of find colors, we're going to be doing certain different pieces there. Finding the color, looking for what that is, and then also sending to the IoT core. You can see at the very top we're using the computer vision libraries and the NumPy libraries to do all the calculations. The next section here is going to be for IoT specifically, where we have the shadow state client that's defined. So this is the shadow that I'm creating. We have the AWS host that's going to be connecting into to do those connections and sending the messages. We have these certificates because at AWS security is job one for us, and we have all these certificates that's going to secure those messages going into the cloud, even if it's something simple as a color of a Postit. Then we have this structure that kind of packages up that information, which is shown there like in the middle with the shadow state of the information that we want to send. So we're going to be sending, something like column 1, blue, column 2, orange, etc. And then finally, section takes care of all the connection times and, how long something should be connected or how it's retried, those types of things. Now that was the IoT section. So now we're going to get into the computer vision. So with computer vision, we set up basic things like the size of the screen, like 640 by 480. Then we also set the aspect ratio of how you want the screen to be. And this next section here is the most important section, and which took most of my time here, defining the colors. So with the computer vision, the camera has to be told what the saturation is, what the value is, what the contrast, things like that. And these numbers that you see there, those 6 pieces of information, is what defines the color blue in this particular case. And the other colors are defined by the other numbers there. So this is what's required for the computer to take a look at something, identify that as a respective color. This next section is simply the colors that I chose for the little dots on top of the Post-its themselves. And this next section is simply setting everything up, zeroing out the values because there's no color or coordinate at this current moment. And then again, this should be kind of familiar now. We're sending up certain piece of information into the cloud to kind of clear out what those actual values are. And you'll see that when I start up the Python script here in a little bit. This next section here is simply getting the colors from all that information that I talked about, and it's going to identify it and it's going to print it out. So the best way to see if this is working well or not is to print it out, and you can see there for that particular color what the coordinates are. So you can see here pink is at those particular coordinates, and these other print statements is just to send all this information so you can see in real time what's happening with that computer vision. This next section simply identifies all the colors, and it looks at the X values. So we don't really care about the Y values here of the coordinates. We're just going to look at the X values. We're going to see which values where, and we're going to put them in ascending order from 0 to whatever it is. And you can see right there, there's 3 zeros and 3 actual coordinates. And I'm also printing it out vertically here. And for this game to be played, you have 6 Post-it notes, but 2 of them are going to be actually off the table at any given time. Because when you have 6 different things to choose from and you're picking 4 of them, again, there could be over 720 different combinations that you're trying to match. And then finally, we're sending all that information up into the cloud, and it's just going to print this information out over and over again. Okay. So the next place here, you'll see as I start it up, it's going to fill those as none, and you see the output coming there. So there's going to be 4 nuns because we haven't matched anything yet. There's no colors identified at this point. Okay, the video will start, and there it is. So the video simply takes a look at these 2 Post-it notes, identifies the colors, makes sure there's more than 500 pixels there, and then calls that yellow, orange, what have you. And you can see the coordinates are being populated there also. It does give the X and the Y coordinate there. So these are just 2 pieces of information, and as I start to move that around, you can see those coordinates are going to be moving around also. So this is real time where we're sending, in this case, there's only 2 Post-it notes. We're sending it about 3 times a second. So with all those coordinates being sent out, that's about 50 messages a second that's going to be sent into the cloud. And you can see all the Post-it notes as I put them on there. They're going to be looked at, identified. The coordinates are going to be created there. And you see them there. Okay, I'm just going to move them around a little bit. And you can see as they're being moved around, those numbers are going to be changed. So keep in mind, the first set that we put up there is what's to be matched. The next ones are what we're moving around. So at first I have 6 of them out there, but now we're going to drop it down to 4, and you can see immediately what's there is going to be matched up. You have purple, blue, yellow, and orange. Exactly what's on the screen there. So the contour lines are shifting a little bit because again, the lighting could be a little bit different, and you can see it's reflected right there and what's being matched. So obviously those are not the correct matching, so we can shift them around. We can switch them and pay attention to how fast that gets switched. So it got switched there, and the orange is actually not being matched right now because again, this is not a perfect science. It's the best that we could do with the computer vision of the camera and how to identify the colors. But again, something fun that we can do, and we're sending all of this into the AWS cloud. So we brought in a green Post-it note there, immediately recognizes it. So we have green, blue, purple, and yellow. Brought in a pink one. The pink is immediately seen there. Pink, green, purple, and yellow. And just like that, in a real game, if we're trying to do a mastermind type of game, we're trying to shift them around and identify the code, you can take guesses, and in real time, it's going to identify that, send it into the cloud, and because you have the shadow there, you can read that information back, and you can, have a specific application for that. So again, keep in mind, I have this set to be sent at, 0.3 of a second. So 1/3 of a second, it sends all this information out there, and that translates to about 50 messages again. You can send that, faster than if you needed to also, but a lot of times you want that message to be updated in near real time. And that's pretty much real time. As you can see, the messages are being recognized, sent to Virginia, and then coming back as well. Okay. Now if you wanted to match those directly, those are being matched. So now we're going to go ahead and put green in there, the blue, and we're trying to basically match the blue, orange, yellow, and purple. And there they are, blue, orange, yellow, and purple. Now if there was a match, you can have some other message come out. You can play some kind of alarm or something like that. So the other thing I wanted to show here also was we were looking at these across the X coordinate. So it really doesn't matter, how they're lined up. They could be, sideways here, like a diamond shape, for example, but we're still looking from left to right. So you can see the orange and the green are not going to get matched because we got rid of those first 2 because we can only have 4 at a time on the screen. Okay. So if I go ahead and remove those 2 out, it's going to, keep the other ones that are out there, and it's going to match those up there. So if you look there, you should have the pink, blue, purple, and yellow, and that's exactly what's shown there. Okay. We can move them around further, and in real time it changes it. It's going to be the pink, purple, blue, and yellow as match, going left to right across the X coordinates. And anytime you change it around, it reflects it in real time. So just something fun, just something, I wanted to see if this could be done, and certainly came, to the fact that the AWS IoT services is more than capable of handling this type of traffic and representing, whatever it is that you want to throw into the cloud there. So that's the end of that particular demo here. I'm going to go ahead and move on to the next slide. So the next slide is basically, what could you do here? What could you do with this type of application, and how can you learn from that? Well, if you don't have an account right now, you can sign up for a free tier account with AWS, and you could use many of these services free for up to a year. Now you can extend this project into something more, maybe take this idea further and productize it into something that's useful for your own needs. Now again, the listing of the diagrams, the architectural views, the GitHub code, the locations, and other artifacts are going to be provided, so please look out for that. And we're also going to have those office hours that I mentioned where you have the chance to talk to myself and others and ask your questions, and we can help you, build something like this and take that further. And those are going to be running for the next 3 weeks. So here are the office hours. So these are the office hours which we're going to be available to discuss the project. So please take note of that. And if you want to join us so we can share further and encourage you to build things, we'd certainly like to help do that. So these are across the different time zones across the world, and we hope that you're able to make one of them. They're going to be running for 3 weeks over 9 different days. So please join us and let us answer your questions. Finally, thank you for your time today, and I hope that you have enjoyed this talk. Please complete the session survey if you have some time. Again, my name is Chana Saminathan. I'm a solutions architect with AWS. Thank you for your time there. I appreciate it. Take care.